Hello everyone. So today I'm just making a quick video of the Let's Make a Baby activity. So that way those of you that are working from home kind of know what's going on. Okay, so just so you guys know, the first thing I need you guys to do is click on this on the agenda. It's going to open up a small PowerPoint. I think it's like 10 slides max. Okay, so what you are going to do if you are doing this is you are going to click File. Oh, sorry, it's still loading. And then you're going to click Make a Copy because you're going to be editing stuff. Okay, so you're going to File, Make a Copy, entire presentation. That way you can edit stuff without changing anything. Okay, so I am going to be explaining what happens on another PowerPoint, but I'll be pointing out the slides on here that you'll have stuff to do on. Okay. So we are on day 2 of the meiosis lecture. Okay. I'm going to be bouncing back and forth between present mode and normal because I have to show you how to edit stuff. Okay. It's taking forever to load, so I'm just going to do it this way. Okay, so first thing you are going to do is you are going to think of a method, an organizational method for these chromosomes. Okay, so if you click on these chromosomes, you can move them. Okay, so these are parent cells. So you have to figure out how you want to organize this array of chromosomes into both of these parent cells. Okay, so take a second and do that. If you need more time, you can always press pause. Okay, so how did your group decide to organize the chromosomes? Color, size, label, etc. Hopefully, yours is similar to this. It doesn't matter if you have green on top or green on bottom, as long as they are labeled 1, 2, 3, organized tallest to shortest. Okay, so if yours doesn't look like this, go ahead and take a second to fix it. Okay, what did you notice about chromosome set 3? Okay, so let's look at chromosome set 3. What is going on there? Okay, if you notice, it's the only one where everyone else is exactly the same size, but this one has a slightly different size. Okay, well, that is because it has to do with gender. Okay, so the chromosome 3 indicates a different gender. So what you are going to do is take a second and you're going to think which one is mom, which one's dad, and you're going to click on the box here and you're going to move the label to assign which one. Okay, so take a second, take a guess. Hopefully you got this. Okay, so chromosome 3 represents the sex chromosomes X and Y. X is bigger than Y. Females have two XX, which are the same size, right there. And males has an XY. One is short and one is super short. Okay, the short one and the super short one. Okay, key term. Sex chromosomes are chromosomes that determine the sex of an individual. Every individual has 2. Males have XY and females have XX. So you are going to, so make sure this gets in your doodle sheet. And this is a visual of an actual set of sex chromosomes. So the males actually are significantly shorter with their Y chromosome versus the 2 females that have 2 very large X's in comparison. So how do parents pass on their chromosomes? Okay, so we already know that we get genetic information from our mom and dad. Okay, so what you guys are going to do is you are going to randomly give the baby, you're going to figure out an organizational method of how to give the baby chromosomes. Okay, so you're going to click on some of these and move them over here. Okay. if you give them this little guy, it'll be male, but if they have two of these tall ones, it'll be female. So what did you give your baby, male or female? So hopefully you have something like this. And if you don't, please edit it so it does. Okay, so you needed to give a 1 from each, chromosome 2 from each, and a chromosome 3 from each. This one happens to be a girl because these chromosomes are the same size. Okay, so this time we're going to do it again, but we're going to add a little bit of a twist. So what you're going to do is you're going to use a coin flip to determine which app you're going to get. So for example, I'm going to open up the Google coin flip. Okay, so let's say I have to give the baby one of these guys. So I'm going to give him 1A or 1B. Let's say A is heads. So I'm going to flip my coin and it's heads. So I'm going to give the baby this one. Okay, and then I need to give one of these two, C or D. Let's say D is heads. And I also got heads. So now I'm going to grab D. Yep. Sometimes this happens. If you put something on there and it disappears, you have to click order and send to back and everything will pop up. Easy fix. Okay, and you're going to do the same thing all the way down. Okay, until you have 2 1s, 2 2s, and 2 3 chromosomes. Okay. I know you're at home, but if we're doing this by chance, do you guys think everyone's baby is going to be the same? Probably not, because the combination of those chromosomes is going to be very, very different, right? Okay, so box C, write down. What criteria or rules did you use to decide how to make a viable baby? So hint, think of the number of chromosomes, think about what mom and dad donate, think about why we flipped a coin, right? Do we get to choose if we're going to have a boy or a girl or their genetic makeup, or when humans have babies, is it kind of up to chance? Okay, if you did not include these in your box C, we're going to add it now. How does the heritable information get from parents to offspring? So the baby needs 2 of each chromosomes. 1 needs to come from each mom and dad. And the chromosomes the baby gets is completely random, much like in real life. Okay, so box D, what actually carries the chromosomes to the baby? That's going to be the sex cell, also known as the gamete. Key terms, gamete, sex cells. The female one is called the egg or ovum, while the sperm is the male gamete. Box E, how many chromosomes are in each gamete compared to the parent cell? Okay, well these, so gametes have half the number of chromosomes compared to the parent cell. Okay, half the number of chromosomes. This is called haploid when you're having half the number of chromosomes and only gametes are haploid. What is it called in sperm and egg meat? Well, that is called fertilization. What new cell is created when the egg and sperm meet? It's called a zygote, which is a cell formed during fertilization. How many chromosomes are in a zygote compared to egg and sperm? That's going to have a normal amount of cells because the 2 gametes each have half. So when they combine, it creates a full set of chromosomes. This is referred to as diploid, indicated by 2N. This is having a full set of chromosomes, 2 of each. All cells except for gametes are diploid. Okay, so now you're going to map out this whole process. Okay, so what you are going to do is, sorry, I left these on here from last period. Okay, so what you're going to do is you're going to so last time we did this, we took the chromosomes from the mom and dad and we basically went straight to the zygote. Now that we know what a zygote is and know there's an intermediate process, we're going to add that. Okay, so what I want you to do is you can even straight up copy the last zygote you created using the coins. So you're going to click on this though. Oops. You're going to right click, go to copy, and hit paste. And it pops up another one. And then you would move that to 1 to the gamete and 1 to the zygote. Okay, because remember, these two combine to form the gamete. Okay, then you're going to move these to where you think they go. So this is already labeled as 2N. Okay, you have to label the sperm, the egg, and I believe this is the word zygote. You can't really see it, it's hidden behind there. Okay, the word zygote, you're going to assign each of these here. You will have to make a copy of one of these two. So you're going to click on it, right click, copy, paste, and it will pop up. Okay, so remember the ovum is the egg. Okay, drag the chromosomes from the female gamete to the appropriate circle on your making doodles and labeled it. Okay, so you should hopefully look like this. Then you're going to do the male. Drag chromosomes to make the male gamete in the appropriate circle on the making babies doodle sheet. Okay, label. So hopefully you'll then look like this. Then you'll have the zygote, which is baby from mom. You're going to have one long, one medium, and short from both mom and dad. Okay. And hopefully it'll look like this. Okay, so now what you guys are going to do is you guys are going to take a screenshot of your last sheet here. And then once you have your screenshot, you are going to paste it into the doodle sheet. I have to show you exactly where, and I totally spaced and forgot to open this up. So please be patient while I pull this up. There's a page on the doodle sheet that I really wish I had thought to delete, but I didn't, because basically it's just what we just did, but way more complicated.